I am Anil Kumar. Welcome to my series on polynomials. Here is mid-chapter review. We have questions based on polynomial characteristics, remainder theorem and factor theorem. I like you to copy these questions, answer them, and then check with my solutions. Question number 1. How many of the following represents polynomials? We have given you 9 functions. You have to find how many of these are polynomials. Question number 2. Graph of a normal polynomial function can have 5 options. None of the following. As you know, graph of polynomials, when we say normal means no restrictions, just the basic ones, right? Next question number 3 is, given function f of x equals to minus 2x squared times x minus 3 whole square times x plus 5 to the power of 4, the number of times that the function f of x changes sign is what? Question number 4. Given polynomial function f of x equals to a times, within brackets k, x minus d to the power of n minus c, where a, k, c, and d are positive integers, which of the following statements is not true for f of x? Now, all these questions should not take more than few seconds to answer. So that's kind of a rapid fire session for you. Question number 5. Write degree of the polynomial function x squared plus 2 whole square minus x times x cubed minus x squared. As an additional exercise, you may write end behavior or may even sketch this function. Question number 6 is, which of the following is an even function? So I hope you remember what is even function. So even functions are symmetric about y-axis, and f of minus x equals to f of x, right? So which is symmetric about y-axis, that is from the graph. And if the equation is given to you, you have to figure out if f of minus x equals to f of x, then it is even function, right? Question number 7. When ax cubed plus bx squared plus 4x plus 1 is divided by x minus 1, the remainder is 12. When it is divided by x plus 3, the remainder is minus 20. Find the product of a and b, right? Not just a and b, but their product. Question number 8. Which of the following is factor of x plus a whole cube plus x plus b whole cube, x minus b whole cube? 5 options. Question number 9. Now this is an application thinking question. I would like you to sketch the graph and explain also why you selected a particular one. Consider the function h of t equals to minus 5t squared plus 10t plus 2 to represent height in meters of a ball after t seconds. In the division statement, h of t divided by t minus a equals to q of t plus r of t minus a. What represents the average change in height of the ball in the interval ta? 5 options are given to you. Now that should be a good review on understanding polynomial functions and their applications. And this will lead us to the next unit, rate of change. Then we have a bonus question. We need to factor unfactorable. So the factored form of f of x equals to x to the power of 4 plus x squared plus 1 is what? Well, as you know, product and sum, 1 is only 1 times 1 or minus 1 times 1. That will not give you the coefficient of x squared. So by normal techniques, you cannot factor this one. Perfect. So you have to think how to factor. Factor and then check the right answer. All look very similar. So all the best. Once you have done these answers, write them down and then check with my solution. If you have any difficulty, post your questions and I'll be very glad to answer them. Thanks a lot and all the best. I hope you got all your answers. Now we'll solve them one by one. I'd like you to understand the concepts as we move along. You can also revisit my videos on these topics. Question number 1. How many of the following represents polynomial functions? These are 9, right? So y equals to minus 2 is a constant and it is a polynomial function. So this is a polynomial function. Now here, this is linear function, right? So this is a line, which is also a polynomial function. Degree 1, this is degree 0. Y square minus x. Whenever you see y squared, then it's not even a function, right? So you could isolate this as y equals to 2 plus x and then square root plus minus, right? So this is not a function. And whenever you see the product x and y, and if you try to isolate y, you will get x in the denominator. So we get negative power. So this is also not a function, right? However, this is a function. If I take all these things to the right side and then square, I could write this as, let me write it down here. Let's say square root of y is equal to, taking these terms, we get 2 minus x, and then squaring, we get y equals to 2 minus x whole square. Do you see that? So these are all the values. And remember here, since y is within the square root, y has to be greater than or equal to 0. That is going to be the restriction, but still it is a function, right? Now this one clearly is a quadratic function. You could have constants as real numbers. Now here we have exponential functions, so it is not a polynomial function. Now in this particular case, let's look into another very interesting example, which is this one. If I cross multiply, I get y equals to minus 2 times x squared plus 1. Now you can see clearly that it is a function, right? Of course, we're going to have y equals to 0. So you could rearrange and check at times. Do you get the idea? Now here this is a sine, so a sine is not a function, not a polynomial function, right? So let's write down, count 1, 2, 3, 4, and 1, 5. And therefore we'll end up with D as the correct option. So this is extremely important question. You need to rearrange and check for yourself whether you could write polynomial function as an x to the power of n plus an minus 1 x to the power of n minus 1 plus so on. Let's say a2x squared plus a1x plus a0, where n is belongs to whole numbers, right? It could be 0, right? And an belongs to real numbers. So that is polynomial. Perfect. The next question here is based on the graph of polynomial. So what we saw was equation from which you could make out whether it is a polynomial or not. This time, graph of a normal polynomial function can be what? Well, when I say normal, I mean we are not imposing restrictions on it. For example, in many applications, in real life, we would like to have x and y as positive numbers, for example, right? So there could be restrictions, right? Sometimes 0 is not permitted when we are solving a particular question. Here, we are not restricting our polynomials. We're just saying normal polynomial functions can have, right? So as you know, graph of a normal polynomial should be a smooth curve. That is very important, right? So graph of a normal polynomial function can have, first option is none of the following. So restricted range, cusp corner, or asymptotes. Well, we know clearly it cannot have the cusp, right? Because this is not a smooth curve corner. We cannot have, nor could you have something like this, right? Those are not there. But what it can have is a restricted range, especially if we have even degree polynomial. In that case, you could actually have y greater than equal to some value. So we could have absolute maximum minimum, correct? So that's the whole idea. So you could have restricted, for example, you could have a function like this. Now in this case, we do have y value which is restricted to greater than equal to, let's say this point is minus b. Do you understand? So that is possible. So that is how this question actually is a very tricky question, and it helps you to understand that the degree of polynomial, if it is even, then the range is restricted, right? You could have absolute maximum or minimum. Question number 3. Given the function minus 2x squared x minus 3 whole square x plus 5 to the power of 4, then the number of times that the function f of x changes sign is what? You are given 5 options. I would like you to actually graph also and verify the result, right? So from the graph, you could see we have zeros at 0. This one is at plus 3, and then we have at minus 5. Now, since leading coefficient is negative, right side is down, correct? And let's count the degree. 4 plus 2 plus 2, that gives you 8, right? So it is even. 8 degree. Is that okay? So both sides are down. Now the question is, the number of times the graph of this function changes sign, right? The number of times that the function f of x changes sign. So changes sign means crosses x-axis. Only then, right? Now you see this is also even degree, so it's going to bounce back. This is again even, this is even degree, it bounces back. That one is also even degree, it bounces back. And the last one is also even degree, it bounces back. And therefore the answer is 0. It never crosses the line, so it never changes the sign. It is always negative, right? Do you understand this part? It is extremely important to understand. And if you graph it, it will be something like this. Does it make sense to you? Extremely important question from test point of view. Now here is question number 4. I'd like you to rethink your answer and then check with my solution. You must have realized by now that there is a lot to learn about polynomials, and in this small set of papers I cannot really cover the whole topic. So I have more than 1,000 videos on polynomials. I would like you to watch them so that you get depth to this particular topic. Similarly, we have lots of videos on other topics. Now let's look into question number 4. Given polynomial function f of x equals to all this, where these are positive integers, which of the following statement is not true for f of x? Maximum number of x-intercepts for f of x is n minus 1. Now, what do you think this function will look like when you sketch it? Well, here what we notice is that it is only moved up or down. Do you see that? Or left or right. Perfect. But it's a cubic function, so n could be either positive or negative, right? N could be either odd or even, correct? So in that case, we have two possibilities. One, now this is minus c. That means graph is moving down, right? So if it is a odd degree function, then it may look like this, right? So it moves right or down depending on these values, right? So it could be like this. Let me go like this. It could be like this, right? Because if c is positive, it moves down, correct? This is minus here. So in that case, what do you notice? Now D is positive means moving to right. So we are expecting that point of inflection to move down somewhere, and in each case we have only one turning point in this particular case. Is that okay? Let us say the degree is 5. N minus 1 gives you 4, so that is not correct. So which of the following statement is not true? Maximum number of x-intercepts is n minus 1. So this statement is actually not true. If you are taking a positive degree function, then basically it's going to look like kind of like this. Right, so it moves right and down, and there will be only 2 x-intercepts. So if n is, let's say, even, let's say greater than equal to 4, even, in that case we have only 2 x-intercepts. You get an idea. But for any odd degree function, we'll have only 1 x-intercept. So this statement is not true. The graph ends in quadrant 1, that is correct. If n is even, then the function f of x will have absolute minimum. That is true. It has absolute minimum. The value of d represents translation to the right. That is correct. So this is the value of d, right? One of the above statement is not true. Well, this is also one of the above statement is not true. So that is also correct. The statement which is not true is actually I wanted to write none of the above. So I wanted to write none of the other. So there's a typing error. Well, we know one of them is not true. So make it none of the above statement is not true. Okay. So that is how you could answer this. I hope it gives you a lot of insight to your learning. Now here is question number 5. Write degree of the polynomial function y equals to x squared plus 2 to square minus x times all this. Now my recommendation is for such questions, expand and simplify. So when you apply the square formula here, you get x to the power of 4 plus 2 times 2, 4x squared plus 4 minus, expand this, right? So we get minus x to the power of 4. And you multiply this, you get plus x cubed. Now what you notice here is that x to the power of 4 and x to the power of 4 cancel. And so we are left with x cubed plus 4x squared plus 4. Now if you are in a rush, you will write 4 as your answer, correct? Clearly you can see that the degree is 3 because that term actually cancels off, right? So the idea here is look carefully. Polynomials introduction may seem very simple, but you can have very tricky questions like you've seen in this particular set. So the idea of mid-chapter review is to expose you to the areas which are prone to errors, okay? Now we have question number 6. Which of the following is an even function? So as I said, even function is symmetric about y-axis, or f of minus x should be equal to f of x. So you have to figure out which one is even. So let's look into this. So if I expand this, I get x4 and x cubed. So this is not even. So whenever you write each term should be even, right? So here if you expand, you get 6 and you also get x to the power of 4. This could be even, right? So we're just checking first. When you multiply, what I'm trying to say here is, if you expand, what you really get is minus x to the power of 4 minus x to the power of 3. Now that is not even, right? In this particular case, when you expand, you get this as equal to 5x to the power of 6. And when you multiply with this, you get minus 5x to the power of 4. Now both these are even terms, so that becomes even function for you. If you do the same here, you get non-even, odd number here. When you do this, that could be, now in this particular case, what we have here, x to the power of 4 minus 1. So this could also be even. So we have 3x to the power of 6 minus 3x squared. Now this function is also even. So in this particular case, we have two even functions. Now here we have, if I expand this, think about x squared outside. Do you understand? So this is actually 3x, x to the power of 8 minus 2, x to the power of 4 plus 1. Now when you expand, you get odd terms, correct? So odd terms means not even. So here we have actually two even functions, right? So which of the following is an even function? Basically we have two here, b and d, right? So following is or are even functions, right? Okay, so there are two which are even functions. You could verify this using f of minus x. So let's do for, let's say d. So we have 3 times minus x to the power of 6 minus 3 times minus x squared is actually equals to 3 times x to the power of 6 minus 3 times x squared, which is the function itself. Do you see that? So we started with f of minus x and we landed up there. So it's an even function. There are two in this example. Correct? Now let's move on to question number 7. When ax cubed plus bx squared plus 4x plus 1 is divided by x minus 1, the remainder is 12. That really means that f of 1 equals to 12. So if I substitute 1 here, I get a plus b plus 4 plus 1, or that gives me 12 equals to a plus b plus 5. Bringing 5 on this side, we get 7 equals to a plus b. So that is one equation. The second one here is, when divided by x plus 3, remainder is minus 2. So you could use your calculator also. So now we'll substitute minus 3 here. So we get minus 3 cubed will make it 27, right? So it is minus 27a. So I'm just substituting minus 3 here. Minus 3 squared is 9 positive plus 9b. Minus 3 will make it minus 12 plus 1. And this value is minus 20. So let me write minus 20 here. Correct? So in this case, let's simplify. So we get minus 27a plus 9b equals to minus 20 plus 12 minus 1. So we'll have to use calculator. Let's use it, right? So we have 12 minus 1 minus 20 equals to minus 9. And we can actually divide by 9 now, right? Or maybe, yeah, let's divide by 9 or maybe minus 9. So if I divide by minus 9, I get 3a minus b equals to 1, right? So we divide by minus 9. It's just a question of solving them. So we have two equations, equation 1 and equation 2. And as you can see, by adding equation 1 and 2, so if I add equation 1 and 2, in that case b is cancelled, perfect. So we are left with 4a equals to 7 plus 1 as 8, and that gives a as equal to a divided by 4, which is 2. So once we get value of a as 2, we can find what b is. B is 7 minus 2, right, which is 5. So we get 5 as the value of b. So when you multiply 5 and 2, you get 10. So we get 5 times 2, which is a times b, and that is 10. So option C is the right option. Perfect. So that's an application of remainder theorem. Let's move on and do question number 8. Question number 8. There was typing error. I actually corrected the question. So those of you who have done the original one, none of the above is the right answer. Now here, the question now is, find factor of x plus a whole cube plus x plus b whole cube plus a minus b whole cube. You can actually pause the video, answer this question, and then check with my solution. Now when I say factor, it really means remainder is 0. So that means we are looking for 0 remainder, right? 0 remainder. So, and if x plus b is a factor, then f of minus b should be equal to 0. So let's figure it out. So if I substitute minus b here, I get minus b plus a whole cube plus minus b whole cube plus minus b whole cube. Now clearly this is not equal to 0, right? Only one term here is 0, but not the other two. The next one you could again do with plus b, right? So if I substitute plus b, right, that means this is plus b. If I do so, again it is not equal to 0, right? That will make this term 0, but the others won't be 0. So now let's look into the next example, which is x plus a. So let's substitute f of minus a. Minus a makes the first term 0, right? The next term, minus a for x, right? Whole cube plus a minus b whole cube. Now this is 0, and that could be written as minus of a minus b whole cube, and this is plus a minus b whole cube, and that is indeed equal to 0. So x plus a is a factor for the given function, right? So that is how you could actually answer this. Now here is question number 9, which is a good application, and actually from here we'll move on to rate of change concept. So it's like a bridge between what we have learned in Unit 1, polynomials, and what we are going to learn in Unit 2, rate of change of polynomials. Okay. Consider the function h of t, which is all this. So it represents height in meters of a ball. So let me just sketch it for you here. So if t is 0, height is 2. So it should be something like this, right? And somewhere it will definitely drop and hit the ground. So this is 2 for us. Perfect. Now the whole idea here is to understand how these polynomial equations are related with real life situations. So on this side we have height, and that is time for us. Now if I say q of t or anything, h of t, right? So what is at any particular, at time t, what is r? Well, let's read the question once again. Consider the function h of t equals to minus 5t square plus 10t plus 2 to represent height in meters of a ball after t seconds. Okay. In the division statement, h of t over t minus a equals to quotient plus remainder over t minus a, what represents the average change in height of a ball in the interval t to a? So now let's consider interval t to a. Let's say this is sometime t, right? And let's say this is sometime a. What do we want to find? What represents average rate of change? That means this slope we want, right? This is what we want to find, right? So it is average rate of change. Is that okay? That is what we want to find. So clearly from here, what you notice is that we could write this average rate of change as rise over run, right? So which is, if I make this triangle here, we are talking about change in y, I should write h, and change in t, right? So let's say h. Okay. So that's what we are talking about. What represents this? So now I hope the question is clear. Which choice is the correct choice for you? It's a very good question. Now, let me show you what this point is. Now, at a time, the value of the function h of t is basically remainder r. Do you understand? So r gives you the value at a function. This is like ra, right? This is ra, correct? So at any time, the value of the function is given by the independent variable. Perfect. That is r, value of the polynomial, right? Okay. So if you rearrange this equation, you can write q of t as equal to, taking this on the right side, h of t over t minus a minus r of t minus a. Do you see that? So you could write this as h of t minus r over t minus a. Now t minus a is this distance, right? Is this distance. Actually, I should have written a on this side and t on the other side. Now, and h of t is this, and r is h of a. So basically, it is h of t minus h of a over t minus a. Do you see that? So you could have any order, doesn't really matter. But t was a general point. I should have taken it later. Okay, but for you, I'll prefer you to switch their places. Is that clear? So this height basically is h of t minus h of a, right? So q of t gives you average rate of change. Option C is the right option. Do you get the point, right? So as per my diagram where I took t some value and then a later on, okay, in that case, we have this value as a minus t. Is it okay? A minus t. So that is how you get rate of change, and clearly it is the quotient which gives you average rate of change. So whenever you divide these polynomials, remember that the quotient represents rate of change. It is normally the answer. So we could also find a rate of change between any 2 points on the curve. Okay. Now this is a very important question. I've taken this as bonus question. Factor unfactorable. I have a few videos on this topic. I'd like you to go through those videos and answer this. Let's see how to answer such questions. The question is, factored form of f of x equals to x to the power of 4 plus x squared plus 1 is what? So one of them is the right answer. So let us see how to factor such expressions. Now clearly 1 product you can get 1 times 1, but here we do not have anything 2. So we cannot really factor this, right? That is why we are saying it is unfactorable. But see, we can actually complete squares, right? So, and then we can apply the concept a square minus b square equals to a plus b times a minus b. So that is the trick involved in solving such questions or factoring such polynomials. So you can actually now take this as a hint, solve, and then check with my solution, right? It's a learning process. Perfect. Now let's write down. So we have x to the power of 4 plus x squared plus 1. Now x to the power of 4 plus 1, I'm rearranging and writing x squared to the other side. X to the power of 4 plus 1 cannot be factored. You know, it does not have real roots, right? But think like this. If I add and subtract 2x squared, then what happens? And why should I add and subtract 2x squared? That is a good question, right? Let's do this. If I have, let's say, a plus b whole square, then it is basically a square plus 2ab plus b squared. Now we have two squares here. That is, we already have 1 square plus 1 square. That means x square whole square in this. The term which is missing is the center term, twice these two quantities, right? So what we could do here is that add and subtract this quantity, twice these two, that means 2x squared. Do you get this concept? Right? This is kind of completing the squares. And then we just write down the last term, which is x squared. So we added and subtracted 2x squared in our trinomial. Does make sense? Correct? Okay. Now it is simple. So these three terms form a perfect square. Correct? These three terms form a perfect square, and you could write them as x squared plus 1 whole square. And here minus x squared is the result. Now this is of the form a square minus b square, and therefore I could write this as x square plus 1 plus x times x square plus 1 minus x. You get an idea. So we have everything positive except for 1 minus x. So in these, everything positive we're looking for except for this minus x. So option D is the right option. Does it make sense to you? So that is how you do this particular question. Now I hope with this, your knowledge about polynomials is around 90%. So to get to 100, I'd like you to visit some more of my videos and do questions from your book. And I hope that helps. Feel free to write your comments, share your views. And how do you like my approach of combining the outdoors to indoors and classroom practice? Feel free to write your comments, share my videos, and post questions as usual. Thanks a lot and all the best.